Good morning, everyone. Today we're going to go over some problems on work and power. During yesterday's class, we covered the definition of work and power. We took notes on this worksheet, which you guys should have in Notability at this point. It's entitled Work and Power Calculations, and the PDF file is in today's Schoology folder if you need to go and find it. If you haven't done this yet, go back to yesterday's lesson. There was a video posted where we talked about the definition of work and power and recorded these notes on those things. So just to review, in physics, work is defined as when a force is exerted on an object and the object moves in the direction of the force. So if you look at my little stick figure picture at the bottom of the page there, you can see my stick figure is applying a force of 10 newtons to the box, right, to the right. The box moves 1 meter in that direction. Okay, since the force and the direction of movement are the same, yes, that is considered work. Okay, in order to calculate the work, I would use the formula work equals force times distance. So I would multiply 10 newtons of force times 1 meter, and that's going to give me 10 joules of work that was done. Okay, the formula for work, once again, is W equals F times D. Work equals force times distance. And if I set my triangle up so I can manipulate my formula to solve for the other variables, I would have W on the top of the triangle, F at the lower left, and D at the lower right. My three derivations of the formula, therefore, if you look on the left there, if I'm solving for work, of course, once again, is force times distance. If I need to find force, then I would take work and divide by distance. And if I need finally to find distance, I would divide work by force. Okay, of course, remember that the units of work are joules. Right, so if I was going to report this up here, force times distance equals 10 newtons times 1 meter is equal to 10, and the work that was done would be 10 joules. Okay, we also talked yesterday about power. So power is a term that describes how fast work gets done. Okay, the rate at which work is done. The formula for power is power equals work divided by time. This is the way it looks in my triangle, with P for power in the lower left, work on the top, and T for time on the lower right. So if I want to change my formula around for power, it would be P equals W over T, W equals P times T, or T equals work divided by power. Okay? Of course, the unit of power that we use is called the watt, which we discussed yesterday, is sometimes seen on light bulbs, those sorts of things. Your power in your house, your electrical usage is measured in kilowatt hours. So it's a term maybe you've seen before. Okay, well, let's look at a few problems. So these are very similar to other problems we've done during the course, speed and velocity problems, etc., etc. So when you do these problems, the first thing you should do is decide what it is that you are solving for. You have two formulas that you can use, right? You could be solving work problems where you have work and force and distance, or it could be a power problem where you have power, work, and time. So by reading the problem, you're going to need to figure out which one is appropriate. The first one says a 5 Newton rock is lifted 2 meters. How much work is done? Okay, so I look and I see 5 newtons is a force, 2 meters is a distance. It's asking me for work. This is going to be a problem that requires the use of the W equals F times D formula because it has those three variables in it. Okay, so as we always start our problems, if I have a problem, I'm going to write out my variables. So W equals, F equals, D equals. Okay, and then I look in the problem and I see what I'm given. I have a 5 Newton rock. Newtons is the unit for force. So I'm going to write in 5 newtons next to F for force. 2 meters is a distance. So I'm going to write in 2 meters. Okay, so my formula, I'm going to find work. W equals F times D is equal to 5 newtons times 2 meters, which is equal to 10. And all I need are the appropriate units of work, which is joules. And there you go. I can circle my answer. Now your problem should be done in the same format, including all the information that I did. Okay, so there are a couple problems where you are doing pretty much the same thing. There are some twists along the way. I'm going to let you guys do some of these on your own. I'm just going to do an example of each. For number 3, for instance, note that it tells us the work and it tells us the distance. And this time we have to calculate the force. Okay, so you might need to change your formula around and use the triangle to find the appropriate formula to solve that problem. But I think you guys can handle that. Again, look at what you're given, plug in your numbers, and figure out what you need to solve for. If you go down to number 4, how much power is used to lift the rock in problem 1 if it is lifted for 5 seconds? And it says use the amount of work you calculated. So you're going to have to pull that 10 joules back off of here in order to plug it down in. But again, this problem now is a power problem, right? How much power is used? Okay, it's giving you time, it's giving you power. So you're going to have to use this formula, the power formula, in order to solve that problem. Okay, I guess we can do one power problem together. Why don't we do that? So I'll do number 4 with you. So how much power is used to lift the rock in problem 1 is listed for 5 seconds. Okay, I'm given work, I'm given time, and it is asking me to find power in this problem. So again, this is the formula that I am going to use, the power formula, not the work one. Okay, so looks like it says how much power, so that tells me I'm going to be looking for power. That's what I'm going to solve for, so I'll put a question mark there. If the rock in problem 1 is lifted for 5 seconds, so 5 seconds, and it says use the amount of work we calculated. So there's problem 1, we calculated that rock, we did 10 joules of work in order to lift it. Okay, so this problem is going to be a power equals work divided by time, which is going to be equal to 10 divided by 10 joules divided by 5 seconds, which is equal to 2, and the units of power are watts. Okay, so my answer is going to be that required 2 watts of power to do that. Okay, I think problem 5 you should be able to do on your own. 6 you can do on your own. 7 is a problem where you have to change the formula around using the triangle. It's going to be your power formula, but you're going to need to change it in order to solve for time, it looks like. And then on number 8, I want you guys to think about this. During yesterday's little lesson, we talked about work and power and how time relates to those two things. So this problem number 8 says, what happens to the power and the work if it only takes half the time to drain the pond? So I want you to think about that and see if you can come up with the right answer. Okay? So your assignment for today is to get this done. When you have completed this, I would like you to submit this PDF, upload it from Notability into Schoology to the assignment that is going to be entitled Work and Power Calculations so that I can grade it. Okay? Good luck, and I hope you have a great day.